we're going to talk about prisms and pyramids and find the surface areas of these types of shapes. Pull out your highlighters. We have a couple of definitions that we need to go through first. Then a colored pencil, something to mark this text to make it stand out for you. Okay, the first one is a definition. So we talked about the bases of prisms the other day, but they're not always rectangular. It could be a triangle, pentagon, hexagon, really any type of polygon can form the base of a pyramid or a prism. When we're talking about a pyramid is a special solid. The way you identify it, it has one base and the same number of triangular faces as there are sides of the base. There is a vertex opposite of the base, and that is the point at which all of the triangular faces intersect. A very important piece of this, when we are doing surface area, is what we call the slant height. The slant height of a pyramid is the distance measured along a triangular face from the vertex to the midpoint of an edge of the base. So in this case, this line right here would be our slant height. Our magic box is going to help you find the slant height. Because we are doing surface area, that is what I need for the height of that triangle. Everybody good on that part? Which part don't you understand, Destiny? I said no. Okay. Now, we're going to skip number 1 for right now and get straight into the finding the different pieces. Do we not have the definition for prisms? We didn't. Okay. Guys, the biggest thing I want you to understand, in a prism, which all 3 of these are prisms, your base shape always has a copy of it at the other end, and there are rectangles in between them. So it doesn't matter if it's a triangle, a pentagon, a hexagon, those are all prisms because the opposite side is the same shape. For all pyramids, you're going to have a base shape. In this case, it was a square. The opposite side is always going to come to one point. So your biggest difference, prisms have 2 identical faces, pyramids have one base and a point opposite of them, a vertex. Are we good so far? Following? Okay, our next page. Go to page 104. Let me add some notes here for you as well. We are recording. Should be. I did. Now you've got me wondering. Let me just double check. No, we're going. Okay, naming pyramids and prisms. The big piece in naming pyramids and prism is, first off, name the base shape. So you start with what the base shape is. That's the first part in naming either pyramids or prisms. And then once you have done that, name the type of solid. In other words, is it a pyramid or is it a prism? A lot of this is going to require some mental manipulation because you're not going to be able to cut out all of these shapes. So you're going to have to mentally fold these up and decide, is the opposite side all coming to one point? If it does, that's a pyramid. or is the opposite side going to be a copy of the same base shape? In that case, it's going to be a prism. But in both cases, when we name them, we start with what the base shape is. Yes, ma'am?
Do you really have to like mentally fold it, or can't you just see if the opposite sides are the same, and then that's how you'd find it?
You can, because that's going to tell you for the prisms. If I only see one base shape, let me rephrase this. Where it really gets confusing is in the triangular prisms and triangular pyramids. Because in both cases, it's a triangle base shape, and then it gets a little tougher to figure out which one it is. So in our first one, part A, 2A, if I fold all of those sides up, what's going to happen? Okay? Meaning that this, what is type of shape is that then? Pyramid. So I start with the base shape. What's my base shape if I'm folding up those triangles? Square. And then when I fold them all up, it's going to make a pyramid. So how do we name that? We call it a square pyramid. Make sense? Okay, the next one. Again, if I fold it all up, what's going to happen?
Because it has the opposite shape, it's the same.
Because it's got two of the opposite shape. The other big key is, are my sides triangles or rectangles? If my sides are triangles, that's a pyramid. If my sides are rectangles, that's going to be a prism. So when I fold this up, those rectangles are all going to come together. What's my base shape?
You have somebody over there raising their hand.
Yes, Brandon. It is a prism, but what's my base shape? Triangular prism. Because when I fold up the sides, these are going to be the sides here. 1, 2, 3 would be my sides, meaning that the parts I circle there are my bases. So this becomes a triangular prism. Questions on naming these shapes? Because even though most of the rest of the exercise doesn't require it, we're going to want you to name every shape you're doing today just to get you used to doing it. Yes, ma'am?
You have one that's sitting here without a book.
That's the hard part on this. And that comes from mentally reconstructing it. A big piece of it is seeing, do I have one shape that's the same or two shapes that are the same? And are my sides triangles or rectangles? So, Maverick, you notice the shock on my face that he's not ready.
So do I need to print?
That would probably be a good idea. Or if you want, I've got an extra one back there. We can just tear the pages out.
Pages out of new books.
Okay. Yes, Liam? Shaped. Yes?
Oh, wow. For B on number 3, would it be a triangular?
Okay. Next up, we're going to draw some nets. So I'm going to give you guys some steps to try to help you. And it's going to be based on what type of shape it is. So, to draw a net, of pyramids. And this is why it's going to help you to be able to identify the shape before you draw the net. The first step is going to be draw the base shape. Second step, draw triangles. Okay. Off of each edge of the base. To draw nets of prisms. Because I'm just writing stuff down for you to copy. We'll practice it in a minute. This one is actually interesting because the first thing I'm going to do is draw the number of rectangles on the prism, and then draw the base shape, one on top, one on bottom. Okay, so I know I wrote that pretty quickly. I'm going to give you guys just a minute to catch up. And then we'll actually look at doing an example of these. Okay, so as you can see, it starts with identifying my figure. So let's look at part A, 3A. What is the figure? Name it for me. What kind of prism?
Triangular prism.
Triangular prism. Remember, when we name it, we start with our base. So this is a triangular prism. So if I look at my notes, drawing nets of prisms, I'm going to draw the number of rectangles on the prism first. So in this case, because it's a triangle, that means there's going to be 3 rectangles. I do 3 rectangles. And then I draw the base shape, one on top, one on bottom. So my base is a triangle. I draw one on top, one on bottom. Pretty easy to do, right?
No. You're literally just folding it. Like it's like
I'm literally unfolding it.
it's origami.
It is very similar to origami. Now, quick question. Is that the only way I could draw this? No. I could have also put the triangles over here, couldn't I? Or I could have put them over here, couldn't I?
Yeah, or you could have literally just taken it.
Okay. But this is the way I prefer to do it. This is just a personal preference. To me, it's actually easier to visualize and refold this mentally when it's all based off of that center rectangle. But either one would work. So is this making sense so far, guys? Okay, we're going to give you a chance to practice. We want you to do part B by yourselves. Not as a table, by yourselves.
All you're doing is drawing the next one.
Okay, again, we start with what is the shape? So what type of shape is part B?
Triangular.
Thank you. We have to say both parts, guys. Start with the base shape, then give the 3-dimensional solid. Triangular pyramid. So, looking at the notes, for the pyramids, I draw my base shape first. Now, technically, because this is 3D, any of those could act as the base, but normally what we do is we draw it in the perspective they've given it to us. So I'm going to say that that triangle is my base shape. So that's the first triangle I'm going to draw. And then I draw triangles off of each edge of the base. So the triangles off of the edges are all going to have the same height, and they're all going to come right off of that. I'm sorry?
It's not what it shows right here.
Because that's not a square pyramid. Oh my goodness, maybe we learned something today.
So smart. You got this behind a good job.
Does that make sense to everybody?
Not really. Yeah.
Who said no? Leanne?
That was not me.
I heard someone right here say no.
That was me.
It was Destiny. I didn't say no. Yes.
Okay,
No.
guys, quiet down.
I said
Is everybody okay with this so far then? Because we're about to make it more complex.
it's kind of confusing.
What's kind of confusing?
Like when you fold it out, and like it's hard to like.
So we're basically just like turning it into a flat piece.
Yes,
Oh, okay.
Yeah, but that's
we're making a net. That's what making a net is, Callie, is making it a flat piece.
this is so easy.
Why are you using such complex words?
Okay,
Net is complex.
2 whole words.
3 whole letters.
I'm actually with Mr. Chan on this one, Callie. Sorry. Okay, just a quick note. Listen up. So on this one, the net of a solid figure is a useful tool when calculating the surface area of a solid figure. So it's actually easier if you just fold it out in a net, because at that point all you're doing is a complex figure. You guys have learned how to do the complex figures already. I just break it into pieces, find those pieces, and then put it all back together. Okay? So we're now going to calculate the surface area of the solid figure represented by each net. So we need to actually do a calculating right now. So in part A, they've given us the figure. The good thing on this one is they actually drew the net for us. Okay? So let's start with naming our base shape. What is this base shape? How did you get that? I just want to see how your mind's working. There's several ways. You are correct. Okay. The big key, if I'm seeing triangles and rectangles together, that's normally telling me it's a prism. The big one, though, is I have two bases that are the same. That tells me prism right there. Plus the rectangles on the sides. Okay? Now here, once we break this down, let's just take a quick second. What do I know automatically about numbers 1 and 2? What do I know about my two bases?
Pardon the interruption. Mr. Fisk, please report to the main office. Mr. Fisk, please report to the main office.
Okay. So 1 and 2, they're the same, the triangles, but they are two bases, but they're opposite.
They're the bases, they're same, and they're opposite. But they're going to be the exact same shape and area, right? So really what I have here, I have the triangle, and then I have 3 different rectangles. So just as we did with our composite figures, if we label them and then figure out the pieces, this should be easy. Now we already said, I know those 2 are the same. So if I find one, I've already found 2, right? That other triangle. So let's go through that. So number 1, what's my base shape? My first step in doing area. What shape is number 1? Right triangle. So that means I put my formula. Area is 1/2 times the base times the height. Then I can go to my figure and label it. Well, I can see right here would be my right angle. So I need these 2 lines. My base is 3. My height, they actually color-coded it for us to make it easier. So I know that my height on this one is 4. Does everybody see that that's the base and height?
Yes.
So now I just put those numbers into my formula. 1/2 times the 3 centimeters times the 4 centimeters. Again, the Mr. Moore hint. If I have an even number, I'm going to take half of 4 and make that a 2. So 2 times 3 gives me 6 square centimeters. Everybody good on that? But how many of those triangles do I have in my shape? 2. So what am I going to do to 6? Does everybody understand that? So for my 2 triangles, this one and this one, that's a total area so far of 12 centimeters squared. I'm sorry? In that case, technically you could have, but I don't want to get you into bad habits. Because that's the single biggest thing student missed on that last test we gave was that last part on shapes. They weren't doing the 1/2s. Number 2, what shape is this? Rectangle. So I know the area equals length times width. So I have a length of 11 and a width of 5. Put those numbers into my formula. Technically I did it the other way. 11 centimeters times 5 centimeters gives me 55 centimeters squared. How many of those rectangles do I have? Just the one. Because this one, they're rectangles, so they're all different. My number 3 is another rectangle. So area equals length times width. This one's a little different. The 3 is now my width. My length doesn't change. It's still 11. So my L is 11. So 11 centimeters. But this time it's times 3 centimeters. Gives me 33 centimeters squared. How many that type of shape do I have? Just the one. Liam, are you getting all this written down? Then I have our 4 shape, another rectangle on the end. I have a length of 4, a height of 11. Length and width gives me 4 centimeters times 11 centimeters, or 44 centimeters squared. So I've now found the area of every piece of this. So to find my total surface area, what do I need to do? Add them all up. Okay? So I already doubled the first one, so I've got 12, 55, 33, and 44. Adding that up gives me 9 plus 5 is 14. I've got 5, 10, 14. So my total surface area is 144. Please, please, please do not forget your units. If all I put is 144, you just failed because that's minus 1/2. You have to have the units. So my total surface area for this prism is 144 centimeters squared.
What is engageny? I like that. That's fun. Just like that. Why do you have to do so much math for one problem?
Because there's a lot of surfaces. I have 5 different surfaces that I have to take into account, Destiny. Questions on anything we covered on this one? Because now is your guys' chance to start getting some practice doing it yourselves. Yes, Sophia?
Oh, I was asking for more time.
Okay, so you've got about 9 minutes until lunch. You should be able to do part B. Again, start by naming what the 3D figure is, then figure out the total surface area. If you
finish with B, turn the page and do A and B on the back.
I was just about to say that. If you finish part B, turn the page, you can do A and B on the next page as well.
Where is it today?
Where's what? It's loose on the back side, but we want to make sure you have another example just in case. Okay, so our first one. Again, we start by naming the shape. What is our shape here?
A squared pyramid.
Excellent. It's a square pyramid. Once I've named it, that should help me break it apart. So I know I've got a square in the middle, and then I've got triangles on the side. One of the biggest issues when you are doing the surface area on the pyramids is making sure you've written down the slant height. The slant height is the distance from along the edge of a face from the base to the vertex on the opposite side. Go ahead, Billy. Okay, my first shape is a square. So the area formula for a square is just square that side. So it's 8 meters squared, or
Get in here.
64 square meters. Shape 2 is a triangle. The base shape for a triangle, or formula, 1/2 the base and the height. They didn't draw the height on the net, so I need to add that one in. It's just my slant height. I do know that all the bases are the same because it is a square, meaning my area is 1/2. My base was an 8. My height is a 10. Again, I prefer to do the 1/2 of an even number if I can. So I'm going to take half of 8, make that a 4. So now it's just 4 times 10, or 40 square meters. But because my base shape is a square, what does that tell me about those 4 triangles?
You have to times them. You have to times the 40 by 4 because there's 4 triangles and no times the area for one.
And because the base is the same and the height is the same, that means I can just multiply that one by 4 because there are 4 of those triangles. Gives me 160 So I've now found all 5 of my shapes. What do I do with my numbers for my final answer? Add them. So my total surface area, if I add the 160 and 64, gives me 224. Do not forget your units. Have I said that often enough yet? Are the units important, guys?
Yes.
Does everybody understand how important the units are?
Yes.
Okay. Is this starting to all come together for you guys? Making sense? Anybody still struggling that we need to get some extra help with? Okay. We're going to give you another page of examples to do. So go ahead and do this entire page. You got 2 and 3, but 2 has 2 parts. So we'll give you guys about another 10 minutes to try to knock all of these out. 10 minutes. So you need 8. Okay, I'm going to go through these relatively quickly because we should be just checking our answers. Okay, remember our first step was identifying our shape. So what shape do I have for 2A?
Square pyramid.
Square pyramid. Once I've identified the shape, that should make drawing the net very easy. Because it's a pyramid, I start with my base shape, which is a square. I draw triangles off each of the sides. So that's a terrible one because triangles should have all been equal. I label it. I have a side of 6 and a slant height of 9, meaning that the height on my triangles are all going to be 9. Meaning I basically have 2 shapes. I've got the square in the middle and the triangles. So I only have 2 pieces that I need to do. This is a square, so it's just the side length squared. Gives me 6 centimeters squared, or 36 centimeters squared. My sides are triangles. So this is 1/2, the base and the height. I have a base of 6, a height of 9. 1/2 of 6 centimeters times 9 centimeters. I can do half of 6, make that a 3, which gives me 27 centimeters squared. However, because this is a square pyramid, all 4 triangles are the same. So I can just multiply this one by 4. 28 gives me 108. Put my pieces together. So the 36 plus the 108 gives us 144. Do not forget your units. Area will always be the units squared because I'm only multiplying 2 of the dimensions. What is my shape for part B? Yes.
Square prism.
Remember, I name it by my base shapes. What's the bases on this one?
Usually when it's sitting on the other.
It's a triangular prism. You were right, and that's part of what messes you up on these. Because I've got the rectangles on all 3 sides, that's kind of what draws your attention first. But remember, in a solid like this, I have 2 identical bases. The 2 identicals are the ones at the ends. So that makes it a triangular prism. Once I've identified my shape, that should make drawing it much easier. Prisms, I'm just going to draw the rectangles first, and then I add the triangle on the sides. Excuse me, this one isn't exactly even all the way around. So the way I've drawn it, I had my base of 12. My height here was 8 centimeters. And then they gave me this side length, so one of the additional ones would be 10. And my side is 15. Okay? So on this one, I'm going to end up with 4 shapes that I need to find. I have my triangle, the base pyramid, and then the rectangles on the ends. It doesn't really matter which order you do it in, but you need to make sure you account for all of them. So my shape 1, we said, is the triangle. So its area is 1/2 the base times the height. In this case, I have a base of 12 and a height of 8. So 1/2 times 12 centimeters times 8 centimeters. That one didn't come out well. 12 centimeters. So I'm going to take half of the 12 to give me a 6. So for this one, it's 48 centimeters squared. But I have 2 triangles. So I multiply that one by 2 to get 96. Shape 2 is a rectangle. So it's length times width. This one I have a length of 12. My width is the same as on the end, or 15. So 12 centimeters times 15 centimeters gives me 150, 180 centimeters squared. Shape 3 is another rectangle, but one big piece on this. This side and this side were both the same, so those are both 10s. So length times width gives me a length here of 10 times the 15 centimeters, or 150 centimeters squared. But I actually have 2 of those, so 3 and 4 are actually identical because this side was 10 and this side was 10. Does everybody understand that? So I could redo that whole thing, or I can just multiply this one by 2. Your choice which way you do it, but you do have to count for all of the different surfaces. So I now have them all. So I have 96, 180, and 300. Gives me 6, 17, 576. So my surface area on this one, 576 centimeters squared. There is my second shape. Now, unfortunately, we're about out of time, so I need to go through the homework. Go ahead and turn to page 115, 116. Pull those out if you haven't yet.
Oh my goodness, you're in math class. Who would have imagined?
She wants to switch to you.
A whole empty paper.
Don't worry, next year you have breaking messages.
Okay, guys, on our first one, please pay attention as we go through the directions. Don't forget your journal entry, especially on my side. I don't think Mr. Chan's caring about that as much. Number 1, guys, please stop.
You're not getting ready. We have not released you. You are paying attention to what he is saying. Stop.
You're naming the solid figure. Do I have to do any calculations?
No.
No, I just need to name the solid figure for each net. In other words, mentally reconstruct it, tell me what you make. Second one, draw a net that will form it. So start on this one by naming the figure. That's going to help you to draw the net. Okay? So name the figure, then draw the net for each of those. Go to 116.
Quit talking, guys.
Now is where we're into calculation. It says it's a cube. That tells you all you need to know about all of the side lengths. Calculate the surface area of a prism. Gave you a length, width, and height. You can draw out a net. And then the last part is a pyramid and the cardboard box. They give you all that information.
Bye, guys. Have a great day.
Oh,
How do you know? Keep going.
you didn't give it to me though.
I felt like